you're able to follow.
Hello.
Right, so we are looking at a survey. Okay, our discussion once again today is based on the notion of what we call probability. So it is this concept here, the concept of probability. Right, now we're going to look at problems that are done at grade 11 on probability. Obviously, this is even seen at primary school, but we are focusing on what the grade 11s need to know. Right. We are beginning with question one. So question one focuses on a survey. A survey was conducted among grade 11 learners on the subjects they do at school. Right. So they do a couple of subjects at school. Right. The survey revealed the following. They do all three subjects. So we have 8 learners who do all the 3 subjects of mathematics, physics, and accounting. Okay. Right. Moreover, 12 do mathematics and physics. Right. So you have 12 learners that do mathematics and physics. Right. So they do both math and physics. We have 5 that do physics and accounting, but not mathematics. Okay. You have X learners that do mathematics and accounting, but not physics. Okay. Right. So let me just pick my writing tool. There's a tool I need to pick that no matter use to make sure that you can be able to see exactly what's on the screen. Right. I'm picking my writing tool now, my highlighter. It's very important that you're able to see exactly the kinds of things I'm describing on the screen as you move along. I believe everybody's able to see the screen. Is that correct? Yes. Right. And everybody's able
Yes, sir.
yeah, everybody's able to hear me as well. Right, so let's continue. Right, I was then saying that you have X students do mathematics and accounting, but not physics. Right, so you have 61 students that do mathematics. You have 19 students that do physics. You have 75 students that do accounting. You have 14 students that do none of the subjects. So what are we supposed to do in this particular question? Is to draw a Venn diagram to illustrate the information above. So now we're going to look at question 1.1 as we draw the Venn diagram. Right, so in 1.1, you need to learn how to draw a Venn diagram. Here is the Venn diagram. Right, so as we draw this Venn diagram, we need to realize a couple of things. Right, let me just extend the Venn diagram a little bit. I want to extend it to make it large enough so that we can put as much information in the Venn diagram as possible. So let me extend it a little bit more. That's okay. Right, so I can extend the Venn diagram to make sure that it can include as much information as possible. Right, and if it includes as much information as possible, then we are certainly very, very safe. All right. Right, so we are here. Right, so it goes up here, the Venn diagram, and it goes all the way to there. We continue. We have this one here. We have this one here. We have an event, or these are basically events, and we have another event here. Right, so if you have those events, right, we note that we have 8 learners that do all 3 subjects of mathematics, physics, and accounting. So we have those students that do mathematics, let's call that M, that event M. Those that do physics, we call that event P. Those that do accounting, we call that event A. Right. If you look at it very carefully, we take note of the following. Right, that in this case, what do we actually have? So we have a total of 61 students that do mathematics. Right, so if you have 61 students that do mathematics and 19 students that do physics, right, you have 14 students that do none of the subjects. So 14 students that do none, it means you put the 14 outside because 14 do none. But 75 students do accounting. Right, so if 75 students do accounting, so X students do mathematics and accounting, but they don't do physics at all. Right, so we need to think about what needs to happen here and make sense of these. I want us to work this out carefully as follows. So I'm going to write here and say for the mathematics. Okay, we're teaching you how to draw Venn diagrams at grade 11. For the mathematics, you shall have some students that do, for instance, small m. I'm going to describe the letters shortly. And there are those students that do X, which is they do mathematics and accounting, but not physics, but they do mathematics. Okay, so there are students that are 8 of them. They do all three, the math, physics, and accounting. So they do math. So we're looking at mathematics. And then we have also the students that are 4, okay, that actually do mathematics. Right, because you have that 12 students do mathematics and physics. So if you look at the math and physics, there are 12 students that do mathematics and physics. Right. So that means, therefore, here you would have a total of 61 students that do mathematics. So the 12 students that do mathematics, but 8 do all three. So if 8 do all three, it means that here you put 8 because they do math, physics, and accounting. So those are 8 of the students. But 12 students do mathematics and physics. So if you look at math and physics, there are 12 of them. So it means that here we need 4 students. So that 4 plus 8 is what? It's exactly 12 students. So we have taken care of this one here. We have taken care of that one there. Right. So I can remove some of these here. I can remove these here and remove that there and remove that here and remove that here as well. Okay, we have these. Right. So we are right back again. We're getting back to analyzing this question on the Venn diagram. So you need to understand it because it's very examinable, but it's also it's grade 11. It's grade 11 work. Right. So you have this situation. Once again, I said 8 students do all three. If 8 students do all three, you look at math, physics, accounting. All three means they are at the point where all the events intersect. The 12 students do math and physics, or math and physics, we have 12. So you have 8 that is common to all, and then you put 4 there because it must be 12. So that 8 plus 4 is 12. I was looking at the fact that now we are looking at the mathematics. Right, so the mathematics here, you can put maybe M here. And then say, right, at this point, you will have what? You have that X do mathematics and accounting, but not physics. So those who do mathematics and accounting, but they do not do physics, and those are X of them. Right, so you can put those here. So now, if you look at M plus X plus 8 plus 4, it's going to give you 61 because those are the mathematics ones. Right, so now we need to make M the subject of the equation. So m is going to become, now you need to add these things up, right? Want to find this one that sits here, right? We just called m for the number of those who do mathematics actually only, right? So in the end, then you'd have that 4 plus 8 is actually 12. 61 minus 12 is 49 minus x. So which means that now you have m, which is equal to 49 minus x. Okay, that's fine. You can just keep that here. Right, so we can actually obviously consider that. So you have 49 minus x. Okay, that's fine. So we keep that here. So in other words, those who do mathematics only, they are 49 minus x. 49 minus x. All right. Next, there are those who do accounting. Right, so those who are doing accounting, right, accounting is sitting here. So there are a couple of things you need to consider, like 5 students. 5 students do physics and accounting, but not mathematics. Physics and accounting, but not mathematics, and there are 5 of those. So here, physics and accounting, but not mathematics, and there are 5 of those. Right. X do mathematics and accounting, math and accounting, but obviously not physics. 61 do mathematics. 19 do physics. 19 do physics. Right, so we actually obviously look at that. But now let's look at those who do accounting, because we already have these, we have that, so you can easily find this one. And then obviously we'll easily find the physics ones. Right, so those who do accounting will therefore become x, this x here, plus 8, plus 5.
5.
Good.
Okay.
Plus 5 plus, okay, you can call it small a here for those who do accounting only. And those who do accounting only, they're a total of how many? They're a total of those who do accounting, there are 75 of them. So you equate these to 75. Okay, because yeah, we're solving Venn diagrams today. Right. So want to find a, what is 8 plus 5? 8 plus 5 is exactly what? It's exactly 13. Right. So 75 minus 13 is 62 minus x.
X.
Means those who are doing accounting are 62 minus x.
X.
Right. So we have that. So now, how many students are doing physics altogether? Right, so now we are interested in those who are doing physics altogether. 19 do physics. 19 students do physics. So we already have these plus that plus that. 4 plus 8 is what? It's actually 12. 12 plus 5 is what? It's actually 17. So in other words, those who do physics only must be 2, because all the physics students must add up to 19. So, but we have 4 plus 8, which is 12, 17 plus 2, which is 19. Okay, we are making progress here. So draw a Venn diagram to actually illustrate the information above. So this is actually the Venn diagram that is required there. So make sure you sort of make sense of these and understand these and what's happening here. Right, so we've drawn the Venn diagram to illustrate the above information. Here's a question. Calculate x. Calculate x. Right, so to calculate x, here is x. The question is, what is x? What is x? Okay, so there are a couple of things, obviously, you need to consider here if you are to be in a position to answer this question. Right, so to get x, there are many ways, obviously, that one can use to get x. But one way that somebody can use to get x is actually to sum all these up. And to imagine how many students are we dealing with actually in this situation altogether? Right, how many students are we dealing with here altogether? So in other words, if we add all the mathematics students, everything here, right, and we add also the students here who are doing none of the subjects, how many are we gonna have altogether? So we need to look into that and think of these very, very carefully, and we therefore proceed as follows. We're gonna add all of them up, right? So let's continue to add all of them up. For instance, right, so we are doing 1.2 here. So we shall add the students 49 minus x. 49 minus x are those who do mathematics. Then we add 4 students, yeah, that do mathematics and physics, but for instance, not accounting. Plus, right, plus 8. So we've added these 49 minus x, 4 plus 8, right? Plus, also we have x students. Plus, we also have 2 students here. Plus 5 students. Plus, we have 62 minus x students. Plus, so we've added pretty much all of them here in the 3 veins. Okay, and then now we actually add also those who are actually outside here that are doing none of the subjects. So those are 14 of them. Right, and so if we add all of them up, right, we're in a position to get a hint of what is happening in this question. So obviously the understanding here is that we are dealing with all these students, but dealing with all these students here, if you add all of them up, you're able to get the total number of the students. And what is the total number of the students? Right, it is understood in this question that we are dealing with a total of 100 students. Right, it is understood that all the students in the school, or the grade 11 learners, are actually 100 students we are dealing with. Okay, that is the understanding. And therefore, if we add all these up, what do you get? Right, so you have x minus x, right? And that gives you 0. And or you can have x minus x, that gives 0. And then you add all these numbers up, the 14, the 62, the 5, the 2, the 8, the 4, the 49, and then you subtract from 100, right? If you do that, I'm expecting that you must be able to get x equals 44. Okay, so you can just do that arithmetic there. So meaning the actual value of x here is actually 44. If we have the understanding that we are dealing with a total of 100 learners altogether. Right, so next point, we are saying here, calculated the probability that a learner chosen randomly does only one of these subjects. The probability that a learner chosen at random does only one of these subjects. So what is the probability? Okay, if a student, for instance, does one of these subjects, what is then the probability that a learner chosen at random does one of these subjects? So we think of this very, very carefully, and we analyze these. So there are a couple of ways, obviously, that one can use to answer this particular question here. Right. For example, if you look at any of these situations here, what would one do to find the probability that a student chosen at random does only one of these? Okay. For instance, if the student does only physics, right, or the student does only mathematics, or the student does only accounting, for instance, what do we then get at this point here. Okay, so let's think of this very carefully and analyze this question and see what we can do precisely. Right, if a student does one of these subjects, suppose a student does only physics. Right, if the student does only physics, what is the probability of that the student does only physics? So you need to, or the student does only mathematics, or the student does only accounting. Right, so you need to think very carefully and realize, for example, because now you know that X is 44. If you can just analyze that and say, if X is 44, let's just put some specific numbers here. Okay, I'm just going to draw these to make it a bit much clearer. Okay, you put X to be 44 and you just substitute. So you have like 44, 49 minus 44, what do you get? You get a 5. Right, in each case here, you get a 4. Okay, maybe that is a bit too small for me to put the numbers. You'll fail to see. Right, so I was saying just put the 44 in the place of the X. So you have 49 minus 44, you get a 5. You get a 2. You get a 5 here. You get an 8. You get yeah, you get a 4. Okay, the 8, I'm just gonna put it outside here. You get a 4 here. Okay, right, and then you get a 44 here. Okay. Okay, let me just put the numbers in the diagram, and then I'm going to put them in circles. So I'm going to say 49 minus 44, you're going to get a 5. Let's put the 5 in a circle. And then here you're going to put the X. So the X is what? Is a 44. So it's sitting there. And then here, what you have a 40, you have a 60, a 62 minus 44. Right, so what is the 62 minus 44? Right, so you need to be able to do your arithmetic correctly to make sure that you give correct answers. Right, so if you have 62 minus 44, you get 18. So here you're gonna get 18. I'm gonna put it in a circle. Then you have the 5, the 8, and so on like that. Right. So looking at these very, very carefully, you look at this and think. Right. So now we think and then say, what is the probability that a student chosen at random does only one of these subjects? So now that would mean you can actually consider one of these. Right. So one of these would be, if a student does accounting only, you have 18. If a student does physics only, you have 2. If a student does mathematics only, you have 5. Right. So in 1.3, right, so you'd have therefore that the probability of this here, right, so you'd have in 1.3, the answer will be written like this. So you'd have 18 for accounting only. You have 18 for accounting only, and then you add the other one. You have for instance 2 for physics only, 2 for physics only, and then 5 for mathematics only. Right, and therefore if you add these, what do you get? You get 25. So which means therefore the probability that the student will do mathematics only will become what? We will do one of these subjects. Okay, so it's either they do physics only, or they do this only, or they do accounting only. So it is 25 out of the total number of the students that have been surveyed, which are 100 students. And so 25 goes, times into 100, it goes 4 times, which is 0.25. Okay.
Not 25.
Yeah. So the probability is that one. Okay, so you think about this because we're just learning probability, and this probability notion is a very important one for us to learn. And we have answered this question one in full, and we move to the next question. We move to the next question. Right. The next question, we shall do it together. Let's look at question 2. Okay. The 120 grade 11 learners. Now we're dealing with a total of 120 grade 11 learners. Right, we're dealing with a total of 120 grade 11 learners. Because in the beginning here, we're dealing with 100 learners. Okay, so here now we're dealing with 120 grade 11 learners. At a school, have 3 extramural activities to choose from. They can either do hiking, or they can do chess, or they can do drama. Okay, so they're allowed to do as many of these activities as they like. So it is possible to do all 3, any 2 or any 1 activity. They may also choose not to do any extramural activity at all. The following information describes this situation. The following information describes this situation. Right, so let's get cracking with this one here. Right, so we continue. We continue. Right, so I'm sure that now we have already seen how to do the Venn diagrams a little bit. Okay, let's continue. They're allowed to do as many of these activities as they like. So it is possible to do all 3. Somebody can do both hiking, chess, and drama, all 3. All right. Any 2 or any 1 activity. They may also choose not to do any extramural activity at all. They can decide, I don't want to do hiking, I don't want to do chess, I don't want to drama. Okay, so they may choose not to do any of them. The following information describes this situation. X learners take only drama and chess. 32 learners take chess. 40 learners take only drama. 6 take hiking and chess, but not drama. 17 learners take chess and drama. 65 learners take drama. 53 learners take hiking. 6 learners do not take any extramural activities. They don't. Okay, 6 take nothing. Right. So draw a Venn diagram to represent the above information. So this one, obviously, I'm gonna do, and I'm gonna do the Venn diagrams in this question, in these questions, as we learn probabilities, calculations. Right, let's look at these here. So to do this Venn diagram, we're gonna proceed like so. We're gonna proceed like so. 120 grade 11 learners at a school have 3 extramural activities to choose from. Either they do hiking, or they do chess, or they do drama, right? Or they do drama like this. Right. Okay, something of that sort. Okay, and there are 120 of these learners. So we're dealing with 120 learners altogether. Right, so let's allocate the numbers. Okay, so here we're gonna put hiking here, capital H. Here we're gonna put the chess learners. Here we're gonna put the drama learners. Okay, so we put the drama here. Now, as usual, here we put H for the hiking learners. Here we put for instance, C for the chess learners, and you can put D for the drama, but yeah, I'll tell you why I'm not putting that yet, because the drama is enough information. But let's first think of these. Well, wait, let's start from the beginning. X learners take only drama and chess. So drama and chess is X, but it's only drama and chess, so they don't do hiking. 32 learners take chess. 32 learners take chess. Right, so if 32 learners take chess, so we can't put the 32 here because they can do chess and it's not only chess. If it was only chess, we're going to put here. But it's a mixture of these potentially. 40 learners take only drama. Okay, this one is nice. 40 learners take only drama, so they're only here, so it's only drama. 6 learners take hiking and chess, but not drama. Okay, 6 learners take hiking and chess, but not drama. And those are 6 learners. 6 learners take hiking and chess, but not drama. 17 learners take chess and drama. So you have 17 learners that take chess and drama. Right, so if you have 17 learners that happen to take chess and drama, right, so you need to think of these. So if they take chess and drama, and those learners are 17, we're going to have a way to distribute those because obviously you need to understand that they take chess and drama, but we know that chess and drama here obviously have a portion of X. X learners take only drama and chess. Okay, so only drama and chess and not hiking. But the 17 take chess and drama. Now I want us to look at those 17 that take chess and drama. Those that take chess and drama, they are 17. So in other words, you must have 17 here, which means we should have 17 minus X. Shall have 17 minus X. So that when you add these, because now those will be chess and drama, they're 17. 65 learners take drama. Right? If you have 65 learners that take drama, right? So let's look at that. Now that is very, very interesting. So 65 letters, they don't take drama only, but in other words, when you add this and that, you get what? You get 65 of those, right? So we shall actually get, we note this one. So we note the totals where they say, these they take chess, these they take drama, these they take, those students take hiking there. Okay, 53 learners take hiking. Again, we note this one because these are the totals for hiking. So the totals where they say total of everything, so we're going to use them to get some unknowns. 6 learners do not take any extramurals. 6 are outside. They don't want anything to do with sport. They don't want to do extramurals. They're scared of hiking, right? So let's do chess. Right, so if you do chess now, right, so the chess is going to be done as follows. We know that 32 learners do chess. So which means that you're going to come to the chess event and add everything. So you're going to have 6, yeah, plus 17 minus X, 6 plus 17 minus X, plus X, plus chess is equal to 32. Because there are 32 learners that take chess. So we just need to solve for C here. Because we know that X minus X is a big 0. So we actually want to get those who do chess only. So you have 32 minus. So this one, 6 plus 17 is what? Is actually 23 minus 32 is actually a big 9. So which means that here we got this one. So these are exactly 9. So the non-students who do chess only, how many students do only drama? Okay, because we know the totals for drama, like we know 65 take drama. So we're going to calculate the drama as well. Right, so those who do drama will become what? Right, so those who do drama, yeah, drama is here, so you can add everything up, but also this portion, we don't know it. Let's call this portion M. It doesn't matter. It's just another unknown. Right, so which is different. The M is different from the H and the C. Right. So now you have this drama. It's going to become everything in the event D. So we have M plus, then you have M plus 17 minus X. You have 17 minus X. Right, you have plus X, and then you have plus 40. So we're adding everything in the drama because now there are 65 learners who do drama. So we know that this is going to become a big 65. Now the implication therefore is, if you add all these, now what is the X minus X is a big 0. And then we have 40 plus 17, which is 57. So now you have the difference, which is M equals 8. Okay, because it's 65 minus 57, which is 8. So it means therefore M here is 8. Okay. Now we have exhausted the chess, we've exhausted the drama. We need to deal with 53 learners that do hiking. Right. So in the 53 learners that do hiking, right, so they do hiking and there are 53 of those, meaning you can add all these guys up here. Right, and if you get all of them up, then you're able to get what we want. So let's deal with the hiking part. So I'm gonna cut here a little bit like this, and I'm gonna deal with hiking. Okay, dealing with hiking, you add everything in the hiking event. So which means that you're gonna have H, those who are hiking only, but you also have plus 6 here, those who are hiking and chess, but not, they don't do drama. And then you have 17 minus X here, right? Because you have H, this 6 plus 17 minus X. So you have plus M. M is what? Is 8. Okay, if you add all this up, what do you get? Okay, look, those who do hiking are 53 learners. You have those who are hiking only, right? You have 6 plus 17, which is actually what? Which is actually 23. 23 plus 8, which is actually 31. Right. So you have 31 minus that, which gives you exactly 22. Plus X. Right. So you have 22 plus X. Those are the ones that are hiking only. Now, draw a Venn diagram to represent the above information. So the Venn diagram has therefore been drawn, and the information has been shown there. Obviously, you can put the rest of this in the Venn diagram. You can put your C is 9. You can put your M is 8. You can put your H is 22 plus X. Right, your M is actually exactly 8. Right, so right, you put your M equals 8. It must not be mixed with the 6. And then also you have about that. Okay, right. So we've drawn the Venn diagram there. These calculations are part of they go with the Venn diagram. Okay, the other things we have done for the chess, the drama, and the hiking. All right, we continue. Now, in 2.2, determine how many learners take only drama and chess. How many learners take only, okay, so they take only drama and chess, so they don't do hiking. So those learners are X. So that is solve for X. What is X in this question? Let's solve for X together. Right, to solve for X, now we need to do what we did before. So we deal with 2.2. Right, so to do 2.2 now, we do the following. So we shall take we want to find x. So to find x, we need to understand that we are dealing with the two events, chess and drama, but not hiking. So that is what we need. So the best way to get x is to do what? Because we do not know exactly how many learners at the moment do x. Do x. That is only chess and drama, but not hiking. So normally when they ask a question like this, you need to add everything up. You need to add everything up. So we start. Okay, so it's a big sum. We take the 22 plus x, which is for hiking only. We add 6. We add what else? We got m, for instance. Okay, right. We got 22 plus x. We add 6. We can add 9 as well. Let's add 9. Doesn't matter. You add everything up. So you add 9. After you've added 9, you add 17 minus x. Okay, 17 minus x. After that, you can add x, which is this one. After that, you add 40, right, which is this one. After that, you add 8, which is this one. After that, you add outside this one, because we have pretty much added everything. Then we add 6, those that do nothing. They don't do any of the 3 extramurals. Okay. And then if you add of them, we're dealing with a total of 120 learners here. Okay, because that's what they told us in the question. They said at the top here, 120 grade 11 learners. That's what they said at the 120 grade 11 learners. So we have these learners there. Okay. What do we do with this now? If you add all of them, you get 120. And so you need to solve for x. You have minus x 0, and then you're left with only a single x. And then you have 120 minus. Right. So now you have 22 plus, you add all the numbers, plus 6, plus 9, plus 17, plus 40, plus 8, plus 6, and then you say 120 minus those. 120 minus 108. Which is 12. So which means it's 12. So which means therefore, those learners that do, we solve for x. We determine how many learners take only drama and chess. We solve for x. Okay. So x is 12. Okay, so we solved for x. Now the question 2.3 says, what is the probability that a learner has chosen at random? Oh, yeah, that a learner has chosen at random, takes all 3 extramural activities. Okay. A learner chosen at random takes all 3. So here we're dealing with the probability of all 3. All 3 activities. Okay, so the probability of all 3 activities. All 3 activities will become what? Now we know that x is 12. So all 3 would be here. So all 3 would be like 17 minus x divided by what? Divided by the total number of all the learners. Okay, so which means it is 17 minus, what is x? X is exactly 12. divided by 120. What is 17 minus 12? It is 5 divided by 120. So if we're saying, which we can simplify to 5 goes how many times into 120? It goes 24 times, and it goes 5 goes once into itself. And therefore, that's one out of 24. What is the probability that Elena has chosen at random, right, takes all 3 extramural activities? It's 1 out of 24. What is the probability that Elena chosen at random takes drama or hiking? So either they take drama or hiking. Right, drama or hiking, right? So let's look at that question there in 2.4. Right, so now, obviously this one is a very interesting question, right? Drama or hiking. Let's do it here. So here we're gonna do 3.4. Right, so what brings the probability of drama or hiking? Drama or hiking? Which is the same as what? So it is the probability of drama. So plus the probability of hiking, you can write like that, minus the probability of drama and hiking. What is the probability of drama? Right, so the probability of drama, we know that 65 learners take drama. So which means that it's going to be 65 out of 120. We know that how many of those that take hiking? There are 53 that take hiking. So you have 53 that take hiking out of 120 minus, there are those that take drama and hiking. Right, so let's look at those that take drama and hiking. So in other words, when you look at these Venn diagrams here, you realize they take drama and hiking. Right, and we have obviously analyzed that part there, because if they take drama and hiking, what did you get M to be? We got M to be 8, okay, and X, what did you get X to be? We got X to be 12. 12 plus 12 plus 8. Is it 12? 12 plus what? Okay, this is 8 plus 5. 8 plus 5, because we got that X is 12. So you say 17 minus 12, which is what? Which is 5. 5 plus 8 is what? Is 13. Good. So it's going to be 13. So those here, it's going to be 13 for drama and hiking.
Hiking.
This is 5 plus 8, which is 13. So you have 13 out of 120. So what is the probability here? So that means that the probability of drama or hiking, which we called capital D and capital H, it's going to become what? Okay, if you add everything up here, you add the top, you add this and that, is subtract 13, you get 105 out of 120. So you have 7 out of 8. You have 7 out of 8. Right, so that's what we have. We have 7 out of 8. So in other words, in 2.4, What is the probability that a learner chosen at random takes drama or hiking? Drama or hiking, it's 7 out of 8. So we've done question 2 on these probability situations. So make sure you sort of try to make sense of these, because these are examinable, and we're doing more probability questions next thing. Okay, so let's look at question 3, more probability. Right, this one is about the people of the Western Cape. Right, so in the Western Cape, a group of 329 people. In the Western Cape, a group of 329 people from the Western Cape speak English, Afrikaans or Xhosa, or combinations of these 3 languages. Okay, so we have those. So we continue. The results of a language survey conducted in this group were stored on Larry Loscope computer. But unfortunately, his files were corrupted. The following facts are all that he has left. 82 people in the survey speak only English and Afrikaans. 8 people speak only Xhosa and Afrikaans. 108 people speak English, only English. 34 people speak Xhosa and English. 143 people speak Afrikaans. 109 people speak Xhosa. Now, we are asking the question, you decide to let the number of people speaking only English and Xhosa be X. Okay, help Larry by drawing a Venn diagram to represent the above information. Help Larry by drawing a Venn diagram to represent the above information. Right, let's draw a Venn diagram. So we're going to help Larry. Right, here's the Venn diagram. We have this one. You have this one. You have this one. Okay. Now, a group of 329 people from the Western Cape speak English. So we have the languages, English, Afrikaans, Xhosa. So let's call the English E. And then we have Afrikaans. We have Afrikaans. And then we have Xhosa. Like that. Okay. Right. So a group of 329 people from the Western Cape speak English, Afrikaans, and Xhosa, or combinations of these 3 languages. All right, let's come here. 82 people in the survey speak only English and Afrikaans. Okay. 82 people speak only English and Afrikaans. So if they speak only English and Afrikaans, it means they don't speak Xhosa, and those are 82. 8 people speak only Xhosa and Afrikaans. 8 people speak only Xhosa and Afrikaans. Okay. Only Xhosa and Afrikaans, 8. So you have only, so they don't speak English. There are 8 of them here. 108 people speak only English. Only English, 108. 34 people speak Xhosa in English. Okay. So if you speak, if you consider Xhosa in English, Xhosa in English, there are 34 people. Okay. Now we're gonna actually attend to the 34 people, because now if you look at the Xhosa in English at 34, so which means that they are here, and these must become 34. So if these must become 34, you have a way to distribute these. So you can say the following. You can say, because if it's 34 people speak Xhosa, you can put them in any way. So you can put here, for instance, if you put here x, and then this one is 34 minus x. 34 minus x. So when you add this up, you get 34 people who speak Xhosa in English. Xhosa in English. Right. So 143 people speak Afrikaans. 143 people speak Afrikaans. So now this is very interesting because it gives us a total. So normally we pick this up. And also 109 people speak Xhosa. So these are the giveaways we normally consider. We come here and we say Afrikaans. So we can put A here. A plus 82. Afrikaans plus 82. The Afrikaans is it's A plus 82 plus 34 minus X plus 8. And realize that those are 143 people who speak Afrikaans. All right, so you have 19. If you add all these here, right, you have 19 plus X. Okay, you add 82 plus 34 plus 8, which is 82 plus 8 is 90, and the 34, and then subtract 143 minus that. Okay, the X is negative. If it comes across, it's going to become a plus X. So which means that A is the same as what? 19 plus X. Next, we also have the total for the Xhosa. 109 speak Xhosa. So which means Xhosa X. Right, the Xhosa, you can put a big X here for the Xhosa, just to make it different from the other small x or lowercase x. So you have X, this one, big X plus the small x, plus we're dealing with the Xhosa now, so you're adding everything here. So you have big X plus small x, but you're also adding 34 minus x. Right. And then you also adding 8. This one. So you've added everything here. But the Xhosa, those who speak Xhosa, 108, 109. 109 is here. Right. So what is this? We want to get big X now. Big X. So big X is X minus X, which is 0, which is 34 plus 8, 67. So X is what? Is 67. So which means that now we have this big X here is 67. Next. Right, next. We continue. We continue. $19. All right. Okay. So the question was, help Larry by drawing a Venn diagram to represent the above information. So we have helped Larry, we have drawn a Venn diagram to represent the above information. And moreover, now after we have drawn this Venn diagram, here is 3.2. 3.2 says use your Venn diagram to solve for X. Where is X? Here. Here it is. 3.2. So now we want to solve for X. Use your Venn diagram to solve for X. Right. To solve for X. Because now they said here, you decide to let the number of people speaking only in English and Xhosa be X. Only English and Xhosa be X. This one. So we want to solve for X. Those who speak only English and Xhosa, but they don't speak Afrikaans. Okay, so 32. So it becomes 108 plus. For now, to get the X, we need to add everything. Everything here. So we add 108. Make sure you jump nothing. Plus 82. So we've added this 82 plus 34 minus X plus X plus 8 plus 19 plus X plus 67. We've added everything right now. We've added absolutely everything. And now as we added everything, this must give us 329. That this is the information we have. Okay. We're not given anything outside here yet. We're not given anything outside the Xhosa. So these people, they speak from the Western Cape, they speak English, Afrikaans, or Xhosa, or combinations of these three. So in other words, then you do not have somebody who is outside here who is not speaking any of these. If we continue, all right, we want to solve for X, right? X minus X is 0, then we have X. If you add 108 plus 82 plus 34 plus 8 plus 19 plus 67, you transpose it, it's going to give you 11. Like this. It's going to give you a big what? It's going to give you a big 11. Okay, so use your Venn diagram to solve for X. Use your Venn diagram to solve for what? To solve
X.
for X. So X is 11. Right. What is the probability that the person selected at random from the group speaks English, Afrikaans, and Xhosa? The person selected at random speaks English, Afrikaans, and Xhosa. So that person is here, is actually there. So that person now in 3.3, it's going to be the probability of the person actually to speak English. They speak English. Let's also speak Afrikaans. And Xhosa. So now, okay, all three that will be here. So that's 34 minus x over 9. Total number of everything. Total number of everything. So we got x to be 11. So you come here, you put
34 minus
11 out of 3 to 9. And so if you subtract 34 minus 11, you get 23 over 3 to 9. So you get 23 over 3 to 9. Right. So that is the probability that the person selected at random from the group speaks English, Afrikaans, and Xhosa. So that person is sitting here, English, Afrikaans, and Xhosa. Okay. What is the probability now? What is the probability that a person selected at random from the group speaks only one language? The person selected at random speaks only one language. What is the probability there? Right, so let's look at that one. They speak only one language in 3.4. So the probability of speaking only one language so we're doing 3.4 now. The probability of saying the person speaks only one language. Right. Right. The probability that the person actually speaks only one language. We continue. We continue. The probability of only one language. Right. So you add the 108. You add 108, you add we got x to be 11. So you add 11 and 19, which is 30. You actually consider 67. Divide by 329. Okay, so 108, 30 and 67. They speak a person who speaks only one language over 3 to 9. So if you add all those up, what you're getting is that, let's add everything up. 108, 30, and 67 added together. That gives us 205 over 329. So the probability that the person speaks only one language is 205 over 329. What is the probability that the person selected at random from the group speaks 2 languages only? 2 languages only. Let's think about this. 2 languages only. Probability of the fact that the person, so we're looking at the 3.5 now. The probability that the person selected random from the group speaks 2 languages only. 6. 2. Two languages only. Two languages only. Right. If the person speaks 2 languages only, what does it mean? So the person can either speak only English and Xhosa, so which means they speak X, or they speak only Afrikaans and Xhosa, which means 8, or they speak just 2. Okay. Right, let's get cracking. Or English and Afrikaans, not Xhosa. So English and Afrikaans, not Xhosa, would be 82. And then now if it's X is 11. So it is English and Xhosa, but not Afrikaans. So you have X is 11. Or you can say, for instance, it's Afrikaans and Xhosa, but not English, 8. Right. Or you have 11 English, Xhosa, but not Afrikaans, 11. You divide everything by 329. So if you add everything up, you get 101 divided by 329. Okay, so this here gives us the probability that the person speaks 2 languages only. 2 languages only. Okay. Next. The next question now is question 4. It is about a total of 283 workers were asked which mode of transport they use to get to work. The results of the survey are summarized below. X workers take a train, a bus, and a taxi to get to work. 110 workers take a train and a taxi. 38 workers take a taxi and a bus. 32 workers take a train and a bus, but not a taxi. 60 get to work by taxi only. 110 workers take a bus. 172 workers take a train. Draw a Venn diagram to represent the information above. Okay, so obviously we understand that here to draw the Venn diagram, we regard the modes of transport. Right, and we consider the 3 modes of transport. So now either somebody is going to take a train, either they take a train, or they take a bus, or take a taxi. In a survey, a group of 283 workers were asked which mode of transport they use to get to work. The results of the survey are summarized below. Right. Now let's analyze these together. So X workers do what? Take a train, a bus, and a taxi to get to work. So X is here. They take everything. Train, bus, taxi. Train, bus, taxi. So they are here. 110 workers take a train and? Right. So the 110 workers, that actually take a train and a taxi. So in other words, they are here, right? So if they are train and taxi, they are here, but this one is already X. So if everything here must be 110, so you must then say 110 minus X. 38 workers take a taxi and a bus. Taxi and bus, right, the taxi and bus, they are a total of what? Of 38. So which means this one is already X. This one is going to be 38 minus X. We continue. Next. Um, all right, we continue. Right, so we continue. Um, 38 workers take a taxi and a bus. Taxi and bus, the 38. This one's already X, so is 38 minus X. Next, so we are done with this one, we're done with this one, we're done with this one. 32 workers take a train and a bus, but not a taxi. Okay, so 32 of them, what do they take? They take a train and a bus, but not a taxi. So now, that's very interesting. So these are only 32. 60 get to work by taxi only. So taxi only, it's 60. Remember, it's taxi only. So it means it's sitting here. It's only taxi. This is only taxi, this. Like this is only bus and this is only train. Okay, probability Venn diagrams, these things you need to learn them at grade 11. They're going to be there in the exam. They're going to, if they've not taught you at your school, they're going to start teaching you this because it's part of what you need to learn. For, I would imagine, it's mostly fourth term work. 110 workers take a bus. Okay, so, but it's not a bus only, because if it could be bus only, we're just going to put the 110 here, bus only. But they take a bus, so it means that it's everything here. Okay, so now this might be easier because this, if you add this and that, this X is cancelled already. And that means if you add this, it's like adding 38 and 32, which give us 70. So now if they give us 70, everything must be 110. So this can only be 40. 70 plus 40 is 110. And that means we are done here. 60, 32, we're done. Okay, this one, 172 workers take a train. Right, so in other words, if you look at the train here, there are 172 workers. This is the train. And then you have right. Okay. Okay, we continue. All right. I was saying now we are dealing with 172 workers that take a train. But 172, they don't take a train only. If they take a train only, we could only be here. But now this one is a little bit tricky because let's see now if you this is minus 2x and that. So if you add everything here, it must be 172. But this and that, the x is cancelled, but there is this one. So you need to obviously simplify that one. Right. Now, we continue with solving this problem. But obviously, in the end, we are trying to draw this Venn diagram. So I'm going to give you a test on the Venn diagrams. So you need to make sure that you listen attentively because the test on the Venn diagrams is going to be very, very important. So you need to make sure that you are very attentive. Otherwise, we want to make sure that you guys pass, but not only that you pass, but we want you to pass with flying colors. We don't want ordinary passes here. We want people to show the world that you are not made of weak material, but you are tough people. So now being tough must be demonstrated in the results that you get. Okay. Simultaneously here, a student can come and say, okay, these things that you put here, if they're not given, you can just say bus. Okay, those who travel by bus, it's you add everything here. And this one you can put a B, small b. If the big B is for bus, you can do that. So which means that you're gonna have 32 plus x, 32 plus x, 38 minus x, 32 plus x, 38 minus x plus b, 110. Okay. It's not degrees, but it's just hello. All right, my dear. All right, so we're continuing just now. We're still here. All right, that's fine. Okay, thank you, my dear. All right, fine. All right, thank you, my dear. All right, all right. Okay, I'm still here. Okay, let's finish this one off. Let's finish this one off. We're doing probability, but Venn diagrams. Okay, so tomorrow we continue with more things and more subjects. Okay, now we're dealing with the bus. Yeah. And then with the bus, you have 32 plus x, so 38 minus x, and then we have the b, the small b. Right, so dealing with the small b, we have the following. Right, so we have the small b. So which means therefore it's 40. Okay, because the x minus x is 0. 32 plus 38 is 70. 110 minus 70 is 40. So you're getting that b is exactly 40. Train. Right, for the train part, you can call this one, you add everything in the train. So you add this plus this plus this plus this. Right, and you get exactly what the train is actually here. All right, obviously we've got the train part. All right, we've got the train part. Right, so the train is going to be the now you need this one. You can call it small t or even big T. But it's for this one only, is for the train only. So for the train, you're going to say, for example, T T plus 32 plus X. T plus 32 plus X plus 110 minus X is 172. So this here is nothing other than the train, because 172 workers take a train. So that's why this time is 172. Okay, if you solve everything here, X minus X, 0. So you have that, okay, just a sec. Okay, we are here. We are here. Let's just stay put and stay tuned. Right, we are here. Right, so we have actually obviously X minus X, which becomes 0. T plus 110 is 142 minus 172, which is exactly 30. So which means this T is 30. All right. All right, so you have exactly that one. Now this is what we sort of get here. So draw a Venn diagram to represent the information above. So we have exactly that. So now in this Venn diagram, what are we supposed to say we have if we have completed the Venn diagram? We must have every region. This region with its own number, this region with its own number, every region with its own number. Okay, so just note that. 4.2, determine the number of workers who take a train, a bus, and a taxi to work. That is X. They take a train, a bus, and a taxi. Train, bus, and taxi to work. So we need to find X. What is X? Right, to get X now, right, it's load shedding, guys. It's load shedding. I did not realize that my load shedding was going to be at 8. I had forgotten. I had forgotten.